Okay, in the last video, I introduced the concept of a solution, and what we want to do now is take this concept further and start to use it so we can apply it to chemistry problems involving chemical reactions that are done in solutions. So this is where we finish. So let's say that we have a container, all right, and in this container we're going to dissolve 5 grams of sodium hydroxide. All right, and so we're going to add the sodium hydroxide to enough water to make 500 milliliters of a solution. All right, 500 mLs or 500 milliliters. All right, and 500 milliliters of solution is equal to a half a liter. All right, and what I want to remind the viewer of is that this is an ionic compound. Sodium hydroxide is ionic. We have a metal that is combined with nonmetals, and in earlier playlists I pointed out, and this is a very important fact that the student of chemistry needs to understand, and that is the following. If we have an ionic compound and it is dissolved into water to make a solution, then that compound is fully ionized. So this is, as the previous video indicated, a solution, and that means we have the even dispersal of solute particles throughout the medium of the solvent. All right, so in this case the solvent is the water and the solute will be the ions of sodium hydroxide. So when sodium hydroxide ionizes, it's going to form Na plus and the polyanion OH minus. I call this a polyanion because it's an anion that contains more than one atom in it. All right, so we're going to have an even dispersal of particles throughout the medium of the water to make a complete solution, which is I'll put this over here just to remind the viewer. So a solution is equal to solute plus solvent. All right, in this case the solvent's the water, the solute is the NaOH. Now what I want to do this morning is to define how we can quantitate or quantify this even dispersal of solute throughout the medium. And we're going to do that by defining a concept called molarity. All right, and molarity is what we call a concentration unit. It is equal to the moles of solute. All right, and mole is a concept we've dealt with before. All right, and we'll talk about how we get to the moles from grams. All right, so it's going to be moles of solute per liters of solution. Per liters of solution. Not liters of solvent, liters of solution. All right, and this can be further abbreviated as moles per liter, like that. Now, I'm saying that this concentration unit molarity is moles of solute per liter of solution. So how do we make this solution in the first place? All right, so let's talk about the practicality of this for a moment. So what we would do if we were going to make a solution using the 5 grams of NaOH, and this is how we would do this in the laboratory. So we would mass out this 5 grams of NaOH, and I'll talk about how we came to the conclusion that we needed the 5 grams. But in this video we're going to stick to how we form the solution in the first place, and then we'll do a couple of basic calculations with it. So we would take this 5 grams of NaOH, and then depending on how precise the solution is going to need to be. For the most precise type of solution, we would need what's called a volumetric flask. All right, and a volumetric flask kind of looks like this. It's got a long glass stem on it with a sort of a bulbous bottom, and then there would be a ground glass mark, which is your meniscus, that's located up on the stem here. And in this case, since we're making 500 mLs of the solution, we would need a 500 milliliter volumetric flask. All right, and if the solution could be less precise, all right, and again, how you decide on this is going to be depending on what your needs are or whatever. You might use a graduated cylinder that would be of the size appropriate to make a 500 ml solution. All right, and what you do here is going to depend on, again, what your needs are. So the volumetric flask is for the precision work, and the graduated cylinder is less precise. And your teacher, your professor, TA, whatever, they'll clue you in on what direction you got to go in on this. Now, what you're going to do is you're going to partially fill the volumetric flask with water, or with the graduated cylinder, you would partially fill that. And then you're going to transfer your 5 grams of material into that water. All right, and you will pre-mix this somehow. In some cases, you may have a magnetic stir bar in here. In other cases, you may just cover. You may just swirl the volumetric flask carefully so that you don't splash material around too much. In the graduated cylinder, you might cover this with what's called parafilm. All right, is what I would do if the solution does not have to be very precise, and then I would mix this up. And then what you're going to do after the material has dissolved is you then adjust your volume up to the correct meniscus for the final solution. All right, and that's how you arrive at this at the denominator of our unit, at the volume of the total solution needed. All right, now let's determine, then let's use the information that we have here to actually find the molarity of the solution that we started with here. So in other words, I took 5 grams of NaOH and I made a solution of it that had a total volume of 500 mLs by one of these two methods. So let's figure out the molarity of this so that we know the concentration now, this uniform disbursement of particles in 500 mLs. So what we need to start with is to find the moles of the material that we massed out. So the moles of 5 grams of NaOH. So we're going to put the 5 grams over 1. And then, like we have done in previous videos, we're going to divide by the molar mass of NaOH. Now, the molar mass of NaOH we would determine by looking up on the periodic table the atomic masses of the respective elements and summing them together. In the interest of efficiency, I've already done that for us. And the molar mass of NaOH is 39.998 grams per mole. All right, so we're going to use the inverse of that value here to find the moles of 5 grams. All right, and what I get when I run the calculation is 0.125 moles of NaOH. Now remember that moles, represents the fraction of particles. So this is actually about 12.5% of Avogadro's number. Just reminding you where we've come from in this whole series. All right, and now what we're going to do is, in order to find the molarity, we need to divide, right? We need to divide by the volume of the total solution, which is 500 mLs. But remember that the unit in molarity is liters. So 500 mLs in liters, all right, is the same thing as taking the 500 mLs and dividing by 1,000 milliliters, and it's equal to 0.5 liters. So we're going to divide this by 0.5 liters, all right, and what we get is a 0.25 molar solution of NaOH. Now, this represents, in finishing, this value, this concentration unit, represents how these particles are dispersed throughout this volume. All right, and now we have a situation where we have a solution and we know what the dispersal is. So if we can cut this solution into fractions if we want. So for example, if I split this volume into quarters, all right, and we pull a quarter of this volume out, which is equal to about 125 milliliters. Now it becomes very simple to know how many particles are in this, because I can convert this number into liters, and we can multiply that times our molarity, which is the fraction of particles, right, per liter of solution. Notice how my liters cancels out, and in a fraction of this volume now, we can know precisely how many or what fraction of Avogadro's number of particles that we've got. So in this case, in 125 milliliters of the solution we just produced, we would have 0.03 roughly moles of NaOH, or about 3% of a mole of particles. And this might be important to us because maybe we have to run a chemical reaction, all right, and we need this many moles in order to do the reaction, all right. So with this, I'm going to close the video.